Today's focus is tangerine, a fruit universally recognized for its sweetness, fragrance, and effortless peelability. Most consumers never realized that while oranges became the industrial standard, tangerines shaped flavor expectations. Every seedless citrus found in supermarkets today is patterned genetically from tangerine properties: thin rind, aromatic cells, pliable pulp membrane, and soluble sugars that do not break into sharp acidity. Understanding tangerine means understanding the modern citrus market. Tangerine stands in a critical branch of the citrus family tree, scientifically aligned with mandarin citrus. Historically, the earliest botanical records reference small, orange-colored fruits with loose peels that detach without mechanical tearing. These early descriptions match what later became classified as tangerine-type fruits. The genetic profile carries high levels of monoterpenous, thin albedo density, and pulp cells that detach from each other without breaking, one of the keys to its eating convenience. The naming origin stems from Tangier, Morocco, once a dominant export port. Fruit shipped from that region entered European trade networks, and tangerine became an identity label rather than a unique species designation. Over time, citrus breeders refined the identity from a shipping origin to a phenotype classification. What separates tangerine from common oranges is cell membrane softness. Each segment casing holds fluid-rich juice sacs, yet the membrane dissolves faster during chewing than orange pulp. This texture profile makes tangerine ideal for fresh eating rather than juicing. Conversely, industrial juice processes rarely rely on tangerine alone. Instead, they blend it to sweeten other citrus liquids without introducing high density or bitterness. Peel morphology remains defining. The outer rind is rich in aromatic oil vesicles. When pressure is applied during peeling, these vesicles rupture, releasing limonene-dominant volatile molecules. Unlike grapefruit rind, which contains bitterness triggering naringin, tangerine peel expresses sweetness-biased aromatic volatiles. Thin rind is controlled genetically through low pectin accumulation. Rind cell walls retain elasticity, meaning that after peeling, segments maintain shape rather than collapsing. This physical property influenced packaging standards. Early citrus crate guidelines in North America were revised specifically because thin-skinned fruits would bruise easily under compression. This forced softer packing materials, tissue separators, and humidity-controlled storage. The global importance of seedlessness began with tangerines. Historically, seed presence in citrus was high due to open pollination. As agriculture industrialized, exporters sought predictable seedless batches. Mutations like Clementine and later selections like Murcott seedless revolutionized international sales. These cultivars directly originate from tangerine lineages, demonstrating how genetic selection influenced consumer psychology. Most supermarket tangerines come from three categories: standard mandarins, including Dancy, Ponkan, and Sunburst types; seedless hybrids, Clementine, Cuties type, Nadorcott; late-season selections, Murcott, honey tangerine. Each category reflects specific cultivation cycles, canopy pruning systems, irrigation frequency, and climate thresholds. For instance, late-season Murcott maintains sugar concentration longer under cool nights, whereas early Clementine ripens quickly and collapses faster post-harvest. From a biochemical standpoint, tangerine contains relatively high soluble sugars, especially sucrose and glucose. Its acidity is mild, primarily citric acid, but buffered by natural potassium salts that create sweetness perception. Volatile compounds include gamma-terpinene, beta-myrcene, and limonene, contributing to its signature rounded fragrance. This chemical spectrum plays a role in beverage formulation. Food engineers rely on tangerine oils to imitate fresh natural citrus essence in sparkling drinks. In agricultural systems, tangerine trees exhibit canopy balance that differs from typical oranges. Branch density forms broader but lighter frameworks, improving sunlight distribution. This enhances pigment formation in fruit skin, increasing color uniformity, critical for export markets. Growers monitor carbohydrate distribution through pruning cycles because overleafing reduces sugar concentration per fruit. The goal is a photosynthesis-driven sugar profile that aligns with standardized market sweetness expectations. Another defining area is post-harvest preservation. Tangerines lose moisture rapidly due to skin microporosity. To slow dehydration, commercial operators apply edible wax coatings. These coatings reduce water evaporation rate, maintain skin elasticity, and extend shelf life. Controlled storage units often sustain 90% humidity to prevent rind wrinkling. When wrinkling appears, it reflects internal moisture migration into airspace, altering membrane tension. Tangerine's culinary presence extends beyond direct consumption. Zest incorporates into marinades, high-temperature baked goods, and confectionery because its aromatic compounds remain stable under heat. Unlike lemon oil, which oxidizes aggressively, tangerine oils maintain sensory integrity even after reduction. Asian cuisines incorporate tangerine peel into herbal infusion blends because peel compounds influence bitterness modulation. In beverage applications, tangerine juice plays two different roles: sweetening agent when combined with strong citrus, aromatic accent to elevate acidity perception. Culinary scientists evaluate pulp suspension quality. Tangerine pulp breaks into microscopic sac fragments easily, allowing smooth integration into gels, yogurt formulations, and sorbets without grainy surface texture. This sets it apart from oranges, which exhibit fibrous separation under mixing. Historically, tangerine became an agricultural cornerstone with the rise of California and Florida's citrus economies. Infrastructures such as refrigerated train shipping emerged partly to maintain tangerine quality. Later, packaging industries developed ventilated plastic crates specifically for delicate peel fruits. Today, genetic studies consider tangerine as a reference genome for hybridization. When breeders search for sweetness, aromatic density, and thin peel architecture, they identify genomic regions inherited from tangerine ancestors. Every major supermarket citrus that peels easily is serving a modern echo of ancient tangerine characteristics. Tangerine changed the idea of citrus consumption: not squeezed, not cut, not prepared, just peeled by hand, eaten segment by segment, leaving aromatic oils in the air. It transitioned citrus from being kitchen-based to being snack-based. This transition influenced school meal systems, vending distribution models, and at-home fruit consumption habits. The modern citrus world still operates under standards created for tangerines, standards emphasizing sweetness, convenience, fragrance, color uniformity, and ease of distribution. Because of that influence, tangerine is not just another fruit, it is one of the pillars of global citrus innovation.